Everyone, welcome to my programming club. Today we will be solving another daily Leetcode problem, and the problem's name is maximum element after decreasing and rearranging. So you are given an integer array of positive integers ARR. You have to perform some operations, possibly zero operations, on this given array to you, so that it satisfies the following conditions or constraints. The first value of the array should be 1, and after that value all of between all of the adjacent values in the array, their differences should be less than or equal to 1. What I mean to say is, uh, let's say array is given to you is or let's take example from the sample test cases itself. Okay, let's take this example. So what the problem statement is saying is, the first element in this particular array should be 1, and between all the adjacent elements, these are the adjacent elements, their differences should be less than or equal to 1. Okay, absolute difference, you can say. So this is what problem statement is asking you to do, and you can perform two operations, one of two operations in one go. Two ops that are available to you are decrease the value, and you can perform them any number of times. Decrease the value of an element of array to a smaller positive integer. So for example, you can decrease value of 2 to 1, but you cannot decrease one's value to 0, since it will not be a positive integer, since 0 is neither positive nor negative. Okay, so the simplest way to solve this problem is to apply sorting. And once you have a sorted array, now let's go back to the previous example. If I apply sorting in this array, then it will be in increase such that it should be in increasing order. So it will be something like this. Okay, this is sorted in increasing order. Now what is expected from you is that first value should be 1. So you can take you can say a variable previous number, and initially it will be having, this is expected from you, previous expected number, you can say previous expected number is 1. So you will be starting from the first index. Let's mark the indices. 0, 1, 2, 3, 4. Starting from this index, you will see what is the value of number at this index. It should be minimum of these two. Then what you expect your next number to be? Next expected number can be at maximum, it can be previous expected number plus 1. Since it is uh, mentioned in the constraints that the adjacent elements can only differ by 1. Okay, so this sorting is being allowed because we are having a operation to rearrange elements. So sorting is allowed here. Sorting is allowed because in one of the operations we can rearrange the array. Okay, so coming back to the next number, expected number, it will be previous expected number plus 1. Okay, now you will update your previous expected number. It will be nothing but previous expected number. Now there are two cases. Since sorting will ensure that sorting will ensure that your current number is either greater than or equal to previous number. Okay, so if it happens that you were expecting, let's say current expected number was 3 and actually you are having 2, so you will update your previous expected number to this. And one case can be this is current expected number and this is actual number you are having. And one case can be that current expected number was 3 and actual number that you are having is, let's say, 7. Okay, then your previous expected number will be updated to 3. Okay, these are the two cases that you should be uh, keeping in mind while solving this particular problem. So your previous expected number will be updated to minimum of current expected number and your actual number. Okay, and at last what you will do is you will return the previous expected number because it will be having the value the maximum possible value in the array following the constraints. Okay, so it will be maximum possible value in the array, max possible value. this is what you will return. Okay. I hope the logic is clear to you. Now let's move towards the implementation part. And I forgot to mention the constraints. You should be checking the constraints first before approaching, before taking some approach to solve the problem, to see whether that approach will be giving you a accepted solution or not, or it is the optimal approach for the input size that is given to you. So your array's length will be of order 10 raised to power 5, and because of sorting, your time complexity will go up to order of n log n, where n being the size of the given array, and since n here is 10 raised to power 5, 10 raised to power 5 log base 2, or you can write something like this. So tight loose upper bound can be 10 raised to power 5, or let's calculate the log base 2 calculator. It was 10 raised to power 5, 3, 4, 5. Okay, so 16 it is. So these number of operations will be required for your solution. Order of number of operations. And it is lesser than the limit of 10 raised to power 8 operations. Basically what happens is, if the number of operations that your solution will be requiring it becomes equal to 10 raised to power 8 operations, or exceeds these number of operations, then you may get a TLE. Here it is lesser, so your solution will be accepted. And those of you who do not know what this concept of operation limit is, I will be providing a link of article describing how the time complexity of accepted solution varies according to input size. A link of article describing this concept will be provided to you. Okay. So, and space complexity wise, since we are not using any extra space, so space complexity wise it will be, S stands for same space complexity. Order of 1. So let's move towards the implementation. So this is the implementation. So this max element is of no use to us. We will not be requiring it. Okay. So I have taken long because the range here was pretty big for the numbers. 10 raised to power 9. So I thought it would be nice to take a large enough variable data type. So you first of all you will sort the array to greedily achieve max value possible in the array following the constants or rules. Okay, and let's rename this previous number to previous expected number. So the previous expected number is initially set to 1 because it's mentioned in the rules that your first number should be 1. Previous expected number is initially set to 1 because it is mentioned that your first number should be 1. Okay, and then you will be updating your previous expected number. Then you will be updating your previous expected number as you move, as you traverse the array from left to right. After sorting it and starting from the first index. Okay, so let's rename this current number also, current expected number, and let's declare another variable, actual number, and previous number, expected number will be updated to the max value possible for actual number in the given array. So it will be minimum of current expected number and the actual numbers values. Okay, these two cases you should be keeping in mind. Which were the two cases? Uh, Current expected number was larger than the actual number, and here the current expected number was smaller than the actual number. Okay, let me take another slide and mention. Current expected number is lesser than actual number. This is one case. Let's say it is 3 and it is 7. Then you will take up 3. And in another case, current expected number can be greater than, or let's say if it's equal, then you will take the current expected number. It is obvious. So that will be a very trivial case. And current expected number, if it's greater than the actual number, let's say it was 3 and actual number is 2, so you will be taking up this number. Or if these both are equal, current expected number is equal to actual number, then you can take any of them. Since they are equal, so uh, any of them can be taken. Okay, so this is what you have to keep in mind, and then you will return your previous expected number, which is carrying the maximum possible number. Then return the previous expected number as it will be carrying the maximum possible number in the given array after applying some operations to make it follow the given rules or constraints. Okay, so let's try to submit it once. As you can see, it's getting accepted. So this is how we will be solving the problem. If you are having any doubts or any queries in general, then please feel free to ask them in the comment section. I will be more than happy to answer. So thank you for watching. Have a great day ahead.